Testing the audio once again. Testing the audio once again. Hello and welcome to Florida Math Exam. We're trying this new format today. I have a new broadcast location for the live stream. So I'm going to get that set up here, and it's going to be a little bit of a cleaner view where you're actually seeing the stream itself happen. It should be a little bit easier to communicate as well. So feel free to participate in the comments here, but I'm going to post in the comments on the video that is live here. And this is the behind the scenes camera, so we can get to know me a little bit better, have a little bit different perspective on the setup here. Just do a quick comment here. And we're broadcasting now to FloridaMathLive.com. You can go there and see what is happening on the document camera. Okay. So that's ready to go, and we are going over the material that we covered in this past week. We started with functions, and we finished up functions, and then we moved into some of the geometry topics. So let's work our way through the solutions on this quiz. Please feel free to post any questions you have, and I will be able to answer those in between the questions that I answer. Okay, so let's get started. All right, so selecting a graph that represents an increasing nonlinear function, we want to mark all that apply. So when we read this, we see increasing, and increasing you want to think of as walking from left to right, that you're going uphill. So that is true on A, B, and C. Those are all increasing. If you were to walk from left to right, you'd be going uphill. But we want something that is nonlinear. So the only linear function we have here would be A, right? It follows a straight line here. And we're looking for a nonlinear increasing function. So that would be B. Okay, so that's number one. Do go ahead and post any questions you have. I can go over more detail on the question itself, and can also answer any other general questions you have, or if you have, say, a summer school question, anything like that, I can help you with. Okay, so the graph here shows the price of a mutual fund over a period of 10 years. And we want to use the words increasing, decreasing, or constant to complete the sentences below. So between 0 and 2, between x equals 0 and x equals 2, so that would be this range here. The function is, if we were walking from left to right, we would be going uphill, so we'd say that is increasing. Between 2 and 4, so that would be from here to here, if we were walking along this from left to right, that would be downhill, so we would call that decreasing. Between 4 and 8, so that would be between here and here, that is neither increasing or decreasing. It's not uphill or downhill. So what we would actually say is that would be constant. Okay. And then between 8 and 10, we'll go back to orange. Between 8 and 10, walking left to right, we would begin again going downhill, so that would be decreasing. Okay. Everyone good so far? Let us know if you have questions about the quiz material we're covering, or if you go to FloridaMathLive.com, you can go in and post questions there to the feed that's at the bottom of that page, and we can interact there. Okay. Move this up here. Give everyone a second to move over. Again, you need to go to Florida Math Live to see what is on document camera. This is the behind the scenes camera, so we can talk a little bit easier. But to see the document camera, you go to that page, and it's a little bit more organized to post your questions. Okay, so the diagram here shows the layout and shape of various exhibits at the zoo. And we want to know which exhibit has a shape that is a translation of the lion's exhibit shape. Okay, so we want to know which is a translation of this. So we want to know what's a translation of this shape here. So a translation, again, is simply sliding something over. So the apes and the birds and the fish, they look pretty similar in shape, but they need to be in the same orientation. Since we're talking about specifically a translation, that would be simply pushing something in some direction. So by the lions, if we were to just simply shift this several units up and 1 unit over, we can see, if we were to follow each of these, it's going to be a congruent slide. Each portion of the shape has the same angles. All of the measures are going to be the same. If you were to look at how many units wide they are, we look at that, it's 1, 2, 3, and 4, 1, 2, 3, and 4. And all of the angles are the same. It's also not rotated or tilted in any way, so we say that the tigers is the correct answer for a translation of tigers is a translation of the lion's exhibit, the shape of it, anyhow. Okay, let me know if you have any questions finding the new location for the broadcast video. Can help you out with that. Let us know if you have any questions about your summer school classes or anything as we get ready for the school year. Okay, next example. The point P is located at -4, 0, and it's translated 3 units to the right and 6 units down to make point P prime. So if we're translating to the right, and we think of this as a XY coordinate, so X, if we remember on a graph, I can draw a little one here. So the X-axis is here, and that's talking about how left and right from the origin we are, and the Y-axis helps us find how far below or above the origin we are. So if something were at -4, 0, and we were going to move it by 3 units to the right, so that would be moving in the positive direction, 3 units, and 6 units down. So down would be for Y, if we're going down 6 units, that would be in the negative direction. So what this would actually look like is if our original spot was at -1, 2, 3, 4. So we're left 4, up and down 0. That would be our original point here. And if we go 3 units to the right and 6 units down, this is what it would look like. So we go right 1, 2, 3, and then down 6 units. 1, 2, 3, 4, 5, 6. So we'll do that in just a different color here. So the new point would be at left of the origin 1. So it'd be -1 and down 6 units, so -6. Okay, so we would have, looks like C at the point -1, -6. All right. Moving right along. So we have the figure shows a quadrilateral ABCD reflected over this dashed line to produce the quadrilateral ABCD prime. So we have the image over here is the after, the pre-image is over here, the before. Okay, so what is it asking? What is the measure of C? So one of the properties of having a reflection, and it's telling us it was reflected, is that the two shapes are congruent. And what that means is this distance is going to be the same measure. Between here and here is the same measure. Both the BC and BC prime is the same measure. And all of the angles are also congruent. So C is congruent to C prime. Angle B is congruent to B prime. So if it's asking, what is this angle? We simply just have to look at what the angle was for C, and it would be the same measure. Happen to be option C as well on the multiple choice. Okay. All right, so if we have the point 4,2 is reflected over a line to form the point 4,0, what line was the point reflected over? So this would be helpful to make, let's do a graph of this. So I'll do the original in blue. So we're over 4. 1, 2, 3, 4, and up 2. That's 0.42. And the image it's saying that happened after the reflection is at over 4, up and down 0. So it's the 0.40. So to get from here to here, if we were reflecting, remember a reflection, there's going to be a line, and it's going to be the same distance from the line that we draw, okay? So what I mean by that is we're going to take half of this distance, and what that ends up looking like is this distance is the same as this distance. So where would that line be? And it's going to be perpendicular to this relationship here. So we would actually have a line of reflection that looks like this, okay? So this is a little bit tricky. The parallel and perpendicular lines, finding the formula for it is always tricky. Essentially what you're looking for is you want to see where it intersects. Okay, we have x equals 1 and y equals 1. Both of those, one of those is a common mistake, one of those is the correct answer. So what we're looking for is does this line cross the y-axis or the x-axis? We'll label those, and of course it crosses the y-axis. Where does it cross the y-axis? It crosses at 1. So we would have the formula for this line, the equation of that line, is y equals 1. Alrighty. I think I need to fix the answer choice on that one. When I make these quizzes, I copy them from the old quiz, so sometimes I forget to double check I made the right answer choice. So we'll go back and look at that after this video. Okay, so which, let's see the whole question here. The figure shows triangle PQR rotated to produce PQR prime. And so this was the original triangle. Okay, it looks like our point of rotation was at P, and it just swung this thing around, right? So we want to get a little bit of an idea of what's happening before we look too much at the questions. And what type of rotation would you say that is? What kind of angle? If we were facing this direction originally for this segment PR, where's PR looking now? What kind of rotation would that be? What kind of angle does that look like? And I would say it looks like a right angle. So that would be 90 degrees. So now let's look at the questions, now that we have a little bit of an idea of what happened. So it wants to know which statement about the transformation is not true. So let's go through these and say which is true or false. PQR is rotated 45 degrees about the origin. Well, it was 90, not 45, and it was about point P, not the origin. So that's false on 2 counts, definitely false. Q, angle Q is congruent to Q prime. So would we say that this angle is congruent to this angle? I would say yes, I'd say that's true. Now the center of rotation is point P. Yeah, that's what we talked about a second ago, that the point of rotation was point P. That was the hinge that we swung the entire shape around, so I'd say that's true. And is PR congruent to PR prime? So let's see where that would be. So if we were to measure this PR, we would find out that that is indeed congruent to PR prime, the distance from P prime to R prime. Okay, so that's also true. So let's see what it was actually asking for again. It's looking for a double negative, right? Where which of these is not true is essentially the correct answer, and the one that was not true was A. So the false one is the right answer. Okay, I'll take one more minute, see if we have any other questions coming up. Let me check the feed. I'll let you ponder this question for just a moment, and we'll be back to work on it together in just a second. Okay, we're back. Let's have a look at this one. So it's telling us the triangle XYZ undergoes a single transformation to form the image XYZ prime. The image is congruent to the original figure, meaning all of the sides are the same length as the corresponding sides of the image and pre-image. There's also all of the angles of the corresponding angles are the same measure in degrees. That's what congruent means again. So which of the following best describes possible transformation that took place? So could it be a reflection only? It could be a reflection, but we'll see about only. A reflection does cause a congruent image, a rotation. The image and pre-image are both congruent in a rotation, so that's true, but is it rotation only and nothing else? A translation is a slide where it just slides over in one direction, also causing all of the sides and angles to be the same, but the image and pre-image are congruent. So far it's all of these. So in this case, a reflection, rotation, and translation are all correct. The one that would be not true is a dilation. A dilation creates a similar image, but not congruent. So it's this as a dilation that we're going to look at things in the next example creates a similar image. There's the same shape, but not necessarily the same size. Okay, getting down to it, we're down on question 9 out of 10. So I'm going to give you just a minute to look at the question we have posted here, and then we'll get back to it in a moment to work on it together. Okay. Give you 30 more seconds to look at that. Okay, so a digital photo on the screen of a smartphone is 5 centimeters wide and 6.5 centimeters high. After we pinch the screen to reduce the size of the photo is reduced to 3 centimeters wide by 3.9 centimeters high. And we're asking, we're asked what the scale factor was that caused that. So let's do blue as the original point. So I'm doing XY coordinates here, remember. And if the original was 5 wide, and the height, actually this should be like a more of a, I'll label this for us, width, height. So we have 5 by 6.5. And then it goes through a dilation. So it goes through something. It's an attempt at an arrow. So what scale factor, what did we multiply these by to ultimately get a width of 3 and a height of 3.9? Okay, so what did we multiply? What would you multiply 5 by to get 3? And what would you multiply 6.5 by to get 3.9? So now we're just getting into some simple algebra. So we do 5 times something gives us 3. So how do we get the x by itself? We divide by 5. X equals 3/5. Okay, so that would be the scale factor that we multiplied this by in order to get to go from 5 to 3. We can also double check that if we wanted to. We could do 6.5. Does this equal 3.9? Question mark. So 6.5 times 3/5. We get 3.9. Leave that up for 1 second. Let us know if you have any questions about this problem or any that you're working on over the summer. And we could do those after we finish the next question, which would be the final question for this quiz. Okay. So the shape shown on the graph below is dilated by a scale factor of 3. And it asks which best describes the shape that is the result of a dilation. So remember, if something goes through a dilation, it's not congruent, it is similar. So what does that mean? It means that it's the same shape still, but perhaps different measures, okay? So how would we label this triangle now? So what we do is we look at this angle here being a right angle, 90 degrees. So it starts as a right triangle, so it's actually going to finish as a right triangle, okay? As a review, an acute triangle would be something where all of the angles are less than 90 degrees. An equilateral triangle is also acute, but it means that all of the sides are equal to each other and all of the angles are equal to each other. And I'm sorry, this is a bad example. That's an obtuse triangle. So an obtuse triangle, because this angle is greater than 90, that's obtuse. So an acute could be anything that is similar to something like this, where all of the angles are less than 90. Acute is also an equilateral triangle. The equilateral also specifies that it has to all have the same angles and all of the same sides. A right triangle means that one of its angles is exactly 90 degrees. Okay, so that was a review of what we covered this week, the solutions for this week's quiz. I'll stay on for one more minute if there's any specific questions you have. And otherwise, have an awesome day. I'll be on for one more minute. Thank you very much.